Hello, fifth graders. Welcome to our next math lesson. Today we're taking a look at chapter 15, lesson 2. It's entitled More Numerical Patterns, and our lesson for today is going to start on page 820. Now, students, if you remember from our lesson, our last lesson, we took a look at numerical patterns where you had to examine one column with the other column, and we found that the relationship between the two, we either had to add or subtract them. And we figured out that one number was always this much bigger than the other number. Today's lesson is very similar to the one we did on Monday, except this week, when you look at the relationship between the two columns, you'll notice that we're going to be dividing, and we're going to figure out that some numbers might be this many times as much as the other number. Now, I know that sounds kind of confusing. Let's get into a couple examples so I can hear you see what I'm talking about. The example that's in your book right here is on the screen. It says, Jack is training for a race. Each week he runs 30 miles and he bikes 120 miles. Okay, so what he did was he created a table to show his progress. Now, how many total miles did he run and did he bike after 5 weeks? And here again is the question we talk about. Can you identify the relationship that comes between the miles that he ran as well as the miles that he biked? Okay, so on this next page here is the same problem, except what we did now is we made the table. So again, it said that Jack ends up running 30 miles every single week. So at the end of the first week, he ran 30 miles. Second week, he ran 60 miles. Third week, 90 miles, so on and so forth. So at the end of 5 weeks, he ran a grand total of 150 miles. We do the same thing with the bike. With the bike, though, the bike's a little different. I'm not adding 30 every time. I'm adding 120 because he did 120 miles each week. So at the end of the first week, he was 120 miles. Second week, 240, then 360, 480, and then finally, he was at 600 miles. So this is very similar to what we did in our last lesson. Making the table, that's different from what we talked about before. But what is different is when you try to identify the relationship between them. Because if you remember from our lesson last time, what we did was we took this bigger number and then we subtracted it from this number. Well, today what you're going to do is you're actually going to do some dividing. Okay, so we're going to actually divide here. So I'm going to change this to a pen here real quick. And we're going to actually divide. We're going to take the 120 because that's the bigger number. So we're going to have 120 and we're going to put that inside the box. And then we're going to divide by 30. Okay, and when we do that, hopefully you remember the secret. The secret whenever you have zeros here is you can just ignore the zeros for a moment. And how many times can 3 go into 12? And that's 4. Okay, so we're noticing that in the first week, he ended up biking 4 times as much than he ran. I'm going to do that with any other numbers. Let's say, for example, I do week 4. Let's take week 4 there. I'm going to put 480. Okay, so I put 480 inside the box here, and then I'm going to put the 120 out front. And again, same rule apply to those zeros. Ignore those zeros for a moment. How many times can 12 go into 48? Again, 4 times. So you should start to see a relationship here, fifth graders, that the number of miles that Jack ended up biking is actually 4 times bigger than the number that he ran. And it's true for every single week because 6 can go into 24 4 times, 9 can go into 36 4 times, and then 15 can go into 60 4 times. So when it says, can you identify the relationship we're going to say here is Jack always bikes 4 times the total miles that he ran. So the total miles he biked is always going to be 4 times the amount that he ran. Here's another example. It says Maria and Henry, they each start a savings account. Okay, Maria is going to put $250 in her account every single month. Okay, then Henry is going to put $125 in his account every single month. The question asked is how much money will they have saved after 6 months? And we got to complete the table. All right, so let's go ahead and complete the table. So Maria is always going to put $250 in her account. So at the end of the first month, it just makes sense that she would have $250. Okay. And then if you add another $250 onto that, at the end of the second month, she's going to have $500. Okay. And then at the end of the third month, all I'm doing is I'm adding 250 every single time. So at the end of the fourth month, there's 1,000. And then at the end of the fifth month, again, add another 250. It's 1,250. And then at the end of the sixth month, she's going to have $1,500. So Maria, this is how much she's going to have in her account after the first 6 months. And all I did here is I added 250 because that's how much Maria is putting in her account every single month. I'm going to do the same thing with Henry. Henry is going to be adding 125 every single time. So at the end of the first month, Henry is going to have 125. Okay. And then if I add another 125 onto that, that'd be 250. And then I'm going to add another 125 onto that, which is 375. And then I'm going to add another 125 onto that, and that gives me 500. And then after that, I'm going to add another one. Sorry about that. My pen is sticking here a little bit. I'm going to add another 125 onto that, and that'd be 625. And then I'm going to add one more 125 onto that, and that's going to be 750. Okay. So I'm going to have 750 here. Now, that's how much Henry's going to have in his account. So this is the account, how much I have in Maria's account. This one's how much I'm going to have in Henry's account. So I filled in the table. Okay, so that part is done. Now the next question, obviously, they're going to ask is, okay, what relationship do you notice between the amount that Maria has and the amount that Henry has? So let's take a look at the first month. Maria has 250 and Henry has 125. If I were to divide these two numbers, if I took 250 and divided by 125, I would actually find out that that answer is 2. What about if I have, after the second month, I'm going to take 500 and divide that by 250. And 500 divided by 250 is, again, 2. And it doesn't matter what row I hear. This is 1,000. This is 500. How many times can 500 go into 1,000? 2 times. So I'm noticing there's a pattern between Maria and Henry's savings. And I'm noticing that Maria will always have twice as much as Henry. Or you could write 2 times as much if you want to say it that way too. That's fine. But every single row, if I took this 1,250 and I divide that by 625, it would be 2. So the relationship there is going to be she's always going to have twice as much as Henry does. Okay. Now, there is a little add-on to this question here that says if Maria and Henry continue to save this way for a full year, how much more will Maria have than Henry? Okay. Well, here, we can come back up here. I know that Maria has saved 1,500 in 6 months. That also leads me to believe that if I were to keep going here, if I added on another 6 months, that's a full year, I can just take 1,500 and double that. Because if it takes her 6 months to get that much, it's going to take her another 6 months to get that much as well. So I would say that Maria is going to have $3,000 in her account. And now it says Maria is always going to have twice as much as Henry. Well, that means then I just have to cut this in half. If I take 3,000, cut that in half, that's 1,500. Okay. So then it says how much more will Maria have than Henry? Well, now I can just simply go ahead and subtract these two numbers together. Okay, and if I do that, I'm going to find out that my answer is $1,500 more. Okay, all right, so they might add on an additional question like this on here. Use your grid here to help you figure out those answers. Let's take a look at one more problem here. It says Sheila and Patrick, they're going to make a table where they're comparing gallons, quarts, and pints. Okay, now this one, they're telling you what rule to use. They're saying use the rule add 4 to complete the column for the number of quarts, which means every single time here, you're going to add 4 every single time. Okay, so with the first quarts, I'm going to add 4. So 0 plus 4 is 4. and I'm going to add 4 every single time. So in 2 gallons, that'd be 8 quarts, okay? And in 3 gallons, that's going to be 12 quarts. And then in 4 gallons, that's going to be 16 quarts. All right. And then in 5 gallons, that's going to be 20 quarts. And then in 6 gallons, that's going to be 24 quarts. So all I did here was I used this rule here, add 4 every single time. Okay. Now, and then over pints, it says use this rule, add 8 for the pints one. So I'm gonna, my first one, I'm gonna add 8, which means the first row here should have 8. Okay. And if I'm gonna add 8 every single time, I'm gonna add 8 onto that, which is 16. And then I'm gonna add another 8 onto that, which is 24. Add another 8 onto that, which is 32. Okay. And then add another 8 onto that, which is 40. And then add another 8 onto that, which is 48. So what I've done now is I've made my chart. I've used the rules that they told me to do. They said add 4 for the quarts one, add 8 for the pints one. Okay, so there's my chart. Now again, they're going to ask me the question. What relationship do you happen to notice about the number of quarts, which is this column, with the number of pints? So I'm not even going to worry about the gallons. I'm just worrying about the quarts and the pints. Well, notice it looks like the pints number is always twice the quarts, right? Because if I take 8 divided by 4, that's 2. Or if I do 16 divided by 8, that's 2. 24 divided by 12 is 2. You get the sense here, right? Every single time, if I divide this number by this number here, it looks like it's going to be 2. So the relationship is there's always going to be twice as many pints as quarts. Or maybe you might write down there's 2 times as many pints as quarts. Okay? All right. So then there's an additional add-on question here. Let's say Patrick has a 12-gallon tank at home. How many quarts of water will fill the fish tank? Okay, well, if I take a look, if 6 gallons is 24, well, then I guess all I have to do is just double this. So another 6 would be another 24. That means then that's going to be 48. Okay, and then there's a second question on here. How many pints? Well, if 6 gallons is 48 pints, another 6 gallons would be another 48. So I'm going to take 48 and add 48, which is 96. Okay, and notice there should always be twice as many pints as quarts. So if I take 96 and I divide that by 48, that answer is going to be 2. Okay, so if you take a look at my pullout here, we see that there'd be 48 quarts and 96 pints. So 5th grade, I hope you're understanding that this lesson is very similar to the lesson we just did the other day, except this time the relationship might be 2 times or 3 times or 4 times or 5 times bigger. Okay. All right, with that being said, let's take a look at your assignment for today. Your assignment is going to be pages 823 and 824. And it looks like you're going to be doing numbers 1 through 8. This hint here, I believe this one was actually for your last lesson. This looks like it was just a mistake on my part, so just ignore this one for a moment. Make sure you're doing numbers 1 through 8 for your lesson for today. Okay. So if you have any questions, don't hesitate to reach out to me. I'm here to help you the best that I can. So I hope you guys do well with this lesson. If you have questions, let me know. Don't be afraid to go back and watch the video. If not, we'll see you with the next video.